Imagine a film director that lives inside your computer.
One that speaks 2 languages fluently, understands cinematic angles, and works 10 times faster than anyone in Hollywood.
That isn't sci-fi anymore. It's the new standard in AI video generation. Welcome to our podcast, Artificial Intelligence, Papers and Concepts curated by Dr. Satya Malik.
It is great to be here. And before we really dive into the deep end of this, we should probably mention something important for our listeners right up top.
Right. If our voices sound a little too perfect, or, maybe our banter is just scientifically calibrated for maximum engagement, there's a reason for that.
There is.
Both myself and my colleague here are, in fact, AI-generated voices.
We're sophisticated code discussing sophisticated code. It's quite meta when you stop and think about it.
It really is. But the research we're unpacking today is very real. We are looking at a new foundation model that is right now sitting at the very top of the artificial analysis arena leaderboard.
And that's no small feat.
No, it's beating OpenAI's Sora, it's beating Google's VO3, and it's beating Kling.
And the name on the door is Seedance 1.0,
Which comes to us from ByteDance.
the parent company of TikTok.
Which I think is a detail we really can't just gloss over. I mean, if you are building a model that needs to understand video, having access to the single largest repository of short-form video on the planet seems like, well, kind of an unfair advantage.
Yeah, it's a massive advantage for sure. But, data is only potential energy. You still need an engine to turn it into kinetic energy. And that's what Seedance 1.0 really is.
Okay.
The mission here wasn't just to, make better video. It was to solve the 3 specific headaches that have really kept AI video stuck in the toy phase.
All right. Lay them out for me. What are the headaches?
Okay, first, unnatural movement, things morphing or floating weirdly.
Yeah.
Second, the inability to follow complex multi-step instructions. And third, and this is the big one, narrative inconsistency.
The amnesia problem.
The amnesia problem, exactly.
Let's dig into that, because I feel like anyone who has played with these video generators knows this pain.
Oh, absolutely.
You generate a character, let's say a robot detective in a rainy alleyway, and it looks incredible.
Right. Perfect shot.
Then you ask for a close-up of the robot's hand, and suddenly the robot is blue instead of silver. Or the rain has just stopped.
Or the alleyway has turned into a forest. The model just creates a new image from scratch every single time. It doesn't have object permanence.
It doesn't know the robot in shot A is the same thing as the robot in shot B.
Precisely.
And Seedance claims to have solved this.
They are calling it multi-shot narrative capability.
Yeah.
And the results are genuinely startling. The architecture lets you generate a sequence. A wide shot, then a medium shot, then a reverse shot.
And the character stays the same.
Exactly the same. The model holds the geometry and the identity of the subject constant across all of them.
So it's not just generating a GIF, it's directing a scene.
It is handling shot-reverse shot logic.
Yeah.
Now, if you're a filmmaker, you know that requires a real understanding of 3D space.
You have to know where the camera is, where the actor is, all of it.
And Seedance seems to build an internal 3D representation of the scene. So when you move the camera, the world actually stays put.
That is the threshold, isn't it? That is the difference between a tech demo and a real production tool.
It totally explains why they're ranking #1 in both text-to-video and image-to-video.
Right, because models usually specialize.
They do. They're good at one or the other. But Seedance 1.0 built a unified architecture that, well, it just dominates both categories.
It's a bold claim. But before we tear the engine apart to see how they're doing it, we need to thank the partners who make this deep dive possible.
This podcast is sponsored by BigVision.ai, a consulting and product development company that helps companies of all sizes build computer vision and AI solutions. You can reach them at contact@bigvision.ai.
Okay, we are back. We have a model from the TikTok giants that can tell a consistent visual story. So I have to know how it works. Is this just a standard diffusion transformer like Sora, or do they really tweak the recipe?
It is a DITA diffusion transformer backbone. That much is pretty standard right now.
Oh.
But they made a very specific architectural choice that really separates them from the pack. They use decoupled spatial and temporal layers.
Decoupled. Okay, break that down for me.
Think about what a video actually is. It's 2 things happening at once.
Yeah.
First, you've got the spatial information, what the frame looks like.
The textures, the colors, the lighting.
The painting task, basically.
Painting. Got it.
Then you have the temporal information, how those pixels move from frame 1 to frame 2 to frame 3. That's the animation task.
Right.
Most models try to solve the painting and the animation in the same processing step. It's computationally Well, it's incredibly heavy.
Like trying to paint a portrait while you're running on a treadmill.
That is, that's actually a pretty good analogy. Yeah. What Seedance does is it splits the brain. It has specific layers that focus only on the spatial details and separate layers that focus only on the temporal connection between frames.
So it paints the picture, then it figures out how the picture moves, but it treats them as two distinct operations.
They coordinate, but they're processed separately. And this saves a massive amount of computing power. But, there's a risk.
What's the risk?
If you separate them too much, the movement can desynchronize from the image. You get that weird warping effect.
Ah, okay. So how do they keep the painter and the animator in sync?
They use something called MMROPE.
Which sounds like a very intense jump roping competition.
It does. It actually stands for 3D multimodal rotary positional encoding.
Okay, that is a mouthful. What does it actually do?
Think of it as a high-precision GPS for every single pixel, but in 4 dimensions.
4 dimensions.
It assigns a coordinate to every piece of data, X, Y, and Z for where it is in the picture, and T for where it is in time.
So the model isn't just guessing, I think the hand moves left. It knows the hand is at these coordinates at frame 1 and needs to be at those coordinates at frame 10.
Exactly right. This rotary encoding allows the model to understand relative positions perfectly. This is the secret sauce behind that multi-shot consistency we were just talking about.
Ah, I see.
Because the model has a coordinate system for the world of the video, if you ask for a reverse shot, it knows mathematically what the back of the character should look like.
So we have a decoupled brain and a GPS for pixels, but a brain is only as good as the books it reads, which I guess brings us back to ByteDance.
The data advantage.
We know they have the quantity, but in AI you always hear garbage in, garbage out. If you train on shaky TikTok dances filmed in a dark bedroom, you're going to get.
Well, shaky, dark video.
Yeah.
That is the trap. And ByteDance knows it. The paper outlines a data processing workflow that is borderline obsessive.
I'm not just dumping the whole database into the model.
No way. It's a curated diet, highly curated. They have 3 main layers of filtration. First is aesthetic scoring.
Okay.
If the video is blurry, has bad lighting, or just looks ugly, it's out. The model never even sees it.
So the AI is a snob. I like it.
Then safety filtering, which is obvious.
Yeah.
But the really clever one is semantic deduplication.
Deduplication. Is that just deleting copies of the same video?
It's smarter than that. The internet is full of viral content, right? The same dance, the same meme, the same cat clip posted 10,000 times.
Sure.
If you train on that, the model overfits. It memorizes that one specific cat instead of learning the concept of a cat.
So deduplication ensures variety. It learns concepts, not just memes.
Precisely. But the visual data is only half the battle. You have to tell the model what it's looking at. A video file is just pixels.
Right, you need captions.
But not just dog and pool. That's not enough for a director-level AI. ByteDance uses a system called Tarsier2 to generate what they call dense captions.
Dense as in detailed.
Extremely detailed.
Yeah.
It splits the description into dynamic features, what is moving, the camera angle, the speed of the action, and static features like the color of the water or the texture of the dog's fur.
I see. That mirrors the architecture we just talked about. The data is split into moving and static, just like the processing layers are.
Exactly. The data pipeline is designed to feed the architecture perfectly. And this is crucial. It does this in 2 languages.
English and Chinese.
Yes. By training on high-quality data in both languages, the model becomes natively bilingual. It's not just translating text, it's translating visual concepts.
So we have the brain and we have the education. But even the smartest students can make mistakes. I know with chatbots like ChatGPT, they use RLHF reinforcement, learning from human feedback to fine-tune things.
Humans voting on which answer is better.
But how do you do that for video? Are they making people watch millions of clips and give a thumbs up?
Sort of, but they automated the judges. This is one of the more surprising parts of the paper. Seedance applies RLHF to the pixels themselves using 3 specific reward models.
Yeah. 3 robot judges.
Think of them as 3 judges sitting at a table, scoring every single video the AI tries to make.
Okay, so who are the judges?
Judge number 1 is the foundational reward model. Its job is simple: obedience. Did the video match the text prompt? If I asked for a car and you gave me a boat, you get a 0.
Harsh, but fair.
Judge number 2 is the motion reward model. This is the physics professor. It checks that the movement follows the laws of nature.
No floating coffee cups.
No floating coffee cups, Do limbs bend backwards, that kind of thing. The don't make it a horror movie judge.
Got it. And the third.
Judge number 3 is the aesthetic reward model. This is the cinematographer. Is the lighting beautiful? Is the composition pleasing to the eye?
So every frame is fighting to satisfy the scriptwriter, the physicist, and the artist all at once.
And to make sure the final result is actually crisp, they use a cascaded approach. This is a great efficiency hack. The base model doesn't try to generate a 1080p masterpiece from scratch,
It makes a rough draft first.
a high-quality rough draft. It generates a 480p video. Then a separate diffusion refiner takes that 480p video and upscales it to 1080p, adding in the fine texture, the hair details, the light reflections.
That's smart. Don't waste energy on high-res pores on a face until you're sure the face is in the right place.
And this cascaded approach is key to the other massive claim they make: speed.
This was my next question. All this complexity, the judges, the decoupled layers, the upscaling, that usually means it's incredibly slow.
You would think so. But Seedance 1.0 is reporting some pretty startling speed numbers. On a single NVIDIA 20 GPU, which is a powerful card but not a supercomputer, it generates a 5-second 1080p video in just 41.4 seconds.
Wow, that's fast. That's roughly 8 seconds of processing for 1 second of video.
Compare that to competitors that can take minutes to render a single second of footage. This moves it from leave it running overnight to go get a coffee and it's done.
So how are they getting that speed? Is it just the decoupled layers?
That helps, but the heavy lifting is done by a process called distillation.
I've heard this term in AI. It's like boiling the model down to its essence.
That's a great way to put it. Think of it like a master and an apprentice. The massive, slow teacher model knows everything. It teaches a smaller, faster student model how to get to the right answer without doing all the long, complex calculations.
So the student basically learns the shortcuts.
They learn the shortcuts. They call it trajectory segmented consistency distillation. Instead of calculating every single tiny step of the diffusion process, the distilled model learns to jump from step 1 to step 10 to step 100, all while maintaining the quality.
So you get the wisdom of the big model, which is the speed of the small one. And they claim a 10x speed up.
A 10x inference speed up. And crucially, without making the model dumber, it still scores high with those 3 judges we talked about.
You know, when you put all of this together, the speed, the narrative consistency, the bilingual capability, it really feels like the goalposts have just moved.
They have. We are not just looking at a clip generator anymore. I mean, you look at the examples in the paper, they show a pixel art helicopter in Manhattan that a felt-style stop-motion fox.
And a realistic news broadcast with a giraffe anchor.
A giraffe anchor wearing a tie. And the text crawl behind it is consistent. The lighting on the giraffe matches the studio environment. It shows the model isn't just copy-pasting objects. It understands the style and the logic of the world it's creating.
Which brings us back to that initial idea, the director and the computer. If Seedance 1.0 is solving the shot reverse shot problem, and it can keep a character consistent.
We're getting very, very close to prompting a movie rather than just prompting a clip.
It makes me wonder about the future of the creator. I mean, if the tool can handle the lighting, the camera angles, the continuity, does the role of a cinematographer just disappear? Or does it change?
I think it evolves. The technical barrier is just crashing down. You don't need to know how to rig a light or pull focus anymore.
So what's left?
That means the vision becomes everything. If anyone can generate a technically perfect shot, the value shifts entirely to the idea, the pacing, the story.
We're moving toward a future where we don't just prompt the scene, but we interactively direct it. Move the camera left, change the lens, make it sadder.
Real-time, interactive cinematography. It's a provocative thought, for sure.
And one we'll probably have to wrestle with sooner than we think. Thank you for joining us on this exploration of Seedance 1.0.
It's been a pleasure.
If you enjoyed this deep dive, please subscribe to the podcast for more insights into the papers and concepts shaping our future. Until next time.